Hi guys, welcome to the third part of the one-dimensional wave equation. In this, we are going to see the function y of x comma 0, which is in terms of sin x. Okay, so this is slightly different from our part 1 and part 2. There we have the algebraic equation. Here it is trigonometric, and how to do this we will see. See, it is given a tightly stretched string with a fixed endpoints x is equal to 0 and x is equal to L is initially in a position given by y of x comma 0 equal to y naught sine q pi x by L, and if it is released from rest from this position, find the displacement y at any distance x from one end at any time t. See, the boundary conditions given are x is equal to 0 and x is equal to L. In this, it is fixed. That means what? If we have y of x comma t as the displacement function, when x is 0, it is fixed. That means there is no displacement at that time. So that's the first boundary condition. We write it as y of 0 comma t, and at the point x is equal to L also it is fixed. Therefore, at the point x is equal to L, again the displacement is 0. And it is given that y of x comma 0, it is nothing but the initial displacement. And one more condition, it is released from rest from this position. That means the initial velocity is 0. Keeping all these four conditions in mind, we have to find the displacement function y of x comma t for the one-dimensional wave equation. We know that the one-dimensional wave equation is given by dou squared y by dou t squared equal to a squared into dou squared y by dou x squared, where a squared is nothing but tension by mass. Okay. See, in this, we know the correct solution for a one-dimensional wave equation is y of x comma t equal to a cos px plus b sin px into c cos pat plus d sin pat. So, we have to choose the solution which is periodic in terms of x as well as in terms of t. Now, we know the boundary conditions. I told you in the beginning itself, at x is equal to 0, it is fixed. Therefore, no displacement. So, it is written as 0. And at x is equal to L also, it is fixed. Therefore, the displacement is 0 at x is equal to L. See, for these two conditions, t values are greater than 0. Now, coming to the initial conditions, it is given released from rest from this position. That means the initial velocity is 0 and the displacement is given, which is a function of sine, that is y of x not equal to f of x is y naught sine q pi x by L, and x takes the values from 0 to L, which is nothing but the length of the string. See, now in the equation 1, we are going to apply these boundary conditions one by one. So, now let us take the first boundary condition y of 0 comma t equal to 0. So, in the equation 1, we have to substitute x is equal to 0. When we do so, it is a cos 0 plus b sin 0 into c cos pat plus d sin pat. We know that sin 0 value is 0 and cos 0 value is 1, and y of 0 comma t is 0 as per the boundary condition 1. So, we have this as 0 equal to a into c cos pat plus d sin pat. See, in this, t is greater than 0, it is the condition given. Therefore, a value equal to 0 is the only possibility. Now, we have to substitute a equal to 0 in this equation. So, therefore, our equation number 1 will be y of x comma t equal to b sin px into c cos pat plus d sin pat. Now, in this, we have to apply the second boundary condition y of L comma t equal to 0. That is, whenever x is taking the value as L, y of L comma t is replaced by 0. Therefore, y of L comma t equal to b sin PL into C cos PAT plus D sin PAT. Now you know that y of L comma T is 0. Therefore, B into sin PL into C cos PAT plus D sin PAT. See, already we have discussed that C cos PAT plus D sin PAT is not equal to 0. And here b is also not equal to 0. Why? Means if you take b as 0 and if you substitute b as 0 here, the entire solution will become 0, which is meaningless. Therefore, we have to consider our sin PL equal to 0. See, c cos PAT plus d sin PAT is not equal to 0. B is also not equal to 0. Therefore, the only option is sin PL equal to 0. Sin PL equal to 0 means it should be a multiple of n pi. So, sin PL equal to sin n pi. Therefore, PL equal to n pi. Therefore, P equal to n pi by L. Now, we have to substitute P equal to n pi by L in our equation number 2. Therefore, we get y of x comma t equal to b into sin n pi x by L into c cos n pi at by L plus d sin n pi at by L. So, with this equation 3, we have to apply the third boundary condition. That is dou y by dou t of x comma 0 equal to 0. So, for that we have to differentiate our equation number 3. So, when we differentiate this equation partially with respect to t, we get b into sin n pi x by L, because differentiation is done partially with respect to t. Therefore, x terms are treated as constant, so that will remain as it is. And we have to differentiate these terms with respect to t partially. Therefore, minus c into differentiation of cos is minus sin n pi at by L into n pi a by L. Similarly, differentiate this. So, we will get it as plus d into cos n pi a by L t into n pi a by L. Okay. So, in this, we know the third condition, dou y by dou t of x comma 0 equal to 0. That is in the above equation. If we substitute t equal to 0, then in the place of dou y by dou t of x comma 0, we have to put 0. So, our left hand side is 0 here, and therefore, we get b sin n pi x by L minus c into t is 0, we are substituting. So, sin 0 is 0, 0 into anything is 0, plus d into cos 0 into n pi a by L. Now, at this stage, we will get 0 equal to b into sin n pi x by L into d into n pi a by L. See, already we have discussed that b is not equal to 0, n is a constant, pi is a constant, a and as well as L are all constants. So, this term cannot be equal to 0. And sin n pi x by L is not equal to 0, because we know that if it is 0, the entire solution will go 0, and therefore, the only option is d equal to 0. Now, we are going to substitute d equal to 0 in our equation number 3, which is nothing but y of x comma t equal to b into sin n pi x by L into c cos n pi at by L plus d sin n pi at by L. So, in that we are substituting d as 0. So, 0 into anything is 0. So, we will be left with y of x comma t as bc into sin n pi x by L into cos n pi at by L. See, and this one, when we multiply b and c, it is it can be treated as a single constant, say b1 or whatever it is, sin n pi x by L into cos n pi at by L. See, by the superposition principle, we can write the most general solution as y of x comma t equal to summation n equal to 1 to infinity bn sin n pi x by L into cos n pi at by L. Now, we are to apply the fourth condition. Fourth condition is nothing but the initial displacement, which is given in our problem. That is y of x comma 0 equal to f of x, and f of x is nothing but our y naught into sin q pi x by L. So, our initial displacement, that means in our previous equation, that is in the most general solution, we had to substitute t as 0. So, when we substitute t as 0, we will get cos 0. Cos 0 value is 1. So, thus we will get this as y naught into sin q pi x by L equal to summation n equal to 1 to infinity bn into sin n pi x by L. See, now in this, normally, if it is other than a function of trigonometric terms, we will be applying the half range sine series in order to determine the bn value. That is what we have done in our part 1 as well as in part 2. But here the function is entirely different. It is not an algebraic function. It is a trigonometric function. Whenever you have a trigonometric function like this, what we have to do is expand the right hand side. Okay, so we have to replace this cube term as a multiple of x. Now it is sine cube pi x by L, so we have to replace that using the formula sine cube of theta equal to 1 by 4 into 3 sine theta minus sine 3 theta. So here our theta value is nothing but our pi x by L. Therefore the left hand side will become y naught into 1 by 4 of 3 sine pi x by L minus sine 3 pi x by L, that is equal to summation n equal to 1 to infinity bn into sine n pi x by L into x. See here in the left hand side we have 1 pi x by L and 3 pi x by L, and we don't have any other terms. So what we are going to do is, let us expand these terms for different values of n. So substitute n equal to 1, we will get it as b1 sine pi x by L, and when n equal to 2, it is b2 sine 2 pi x by L. When n equal to 3, it is b3 sine 3 pi x by L. N equal to 4, b4 sine 4 pi x by L, and so on. So let us compare the likely terms, that is sine pi x by L is here, and here also we have a sine pi x by L. So when I compare the left hand side and the right hand side, sine pi x by L, here in the right I have a b1, but in the left hand side I am having 3 y naught by 4. Therefore the b1 value is nothing but 3 y naught by 4. Now similarly compare the sine 2 pi x by L term. There is no 2 pi x by L term here, so that is treated as 0. Therefore b2 value is 0. Next term, there is a 3 pi x by L term with a sine. Okay, and here also we have a sine 3 pi x by L term. So let us compare b3 with its coefficient. Therefore b3 equal to minus of y naught by 4, and we don't have the other terms in the sense we are not having b4 b5 in the left hand side, so we have to take them as 0. So it is b4 b5 and so on, b6 are all equal to 0. Now we are going to substitute the values of this b1 b2 b3 as well as b4 b5 and so on. We know that from b4 it is 0, so we won't get a series, but we have a finite series since our b4 b5 b6 and so on up to infinity are all 0. So our solution y of x comma t equal to, now we know the most general solution in that for 1 b1 we will get sine pi x by L, and here it is cos pi a t by L, b2 into sine 2 pi x by L into cos 2 pi a t by L plus b3 into sine 3 pi x by L into cos 3 pi a t by L and so on. See, we can restrict it as a finite series. We know the values of b1 is 3 y naught by 4. So 3 y naught by 4 into sine pi x by L into cos pi a t by L. b2 term is 0, so we are omitting it, and b3 is minus y naught by 4 into sine 3 pi x by L into cos 3 pi a t by L. So this is the required displacement for the string with the initial displacement y naught into sine cube pi x by L. So thus we have come to this end of the problem. Keep watching, and we are yet to come with a few more problems from two-dimensional heat equations. Thank you for watching.